Alrighty, so we are talking about mirages. And as we discussed in the last video, there's sort of this issue here that as you heat something here, the molecules tend to get further apart, versus if they're sort of cooler, they tend to be closer together. And we discussed also that if this has an index refraction of being hot and this has an index refraction of being cold, then the cooler index refraction is going to be greater than the hotter one because it's more dense. And if you recall the index refraction table from a few videos ago, the denser materials just have a higher index refraction. Air starts around 1, water is at 1.33, glass is at 1.5, and so on and so forth. So we'd expect that cooler, more dense materials have a higher index refraction. And you can even take this step further to say something like the index refraction of some material might be, even loosely speaking, proportional to 1 over the object's temperature. I don't know if it's quite like this, but there's definitely an inverse feeling to it. Okay, an inverse feeling to it. And all I'm saying is that the hotter something is, like air, the smaller the index refraction is going to become. So air becomes less dense, its index refraction goes down. If you cool air, it becomes more dense, its index refraction goes up, and vice versa. So this is not a law of physics that we should memorize, and you're not going to find that in the book anywhere, but that's definitely the feeling you get for index refraction. So here's the way it goes. I guess that's sort of part one for mirages here. And let's get into the rest of it here, a diagram to show you sort of what's happening here. So here's that dark road again, and which is usually hot. And here you are in your car. Maybe you're like in a Tesla Model 3 or something like that. There you go, you're driving down the road. And so, of course, you have the air above you now. So I'm not going to draw the air for a minute, just for a moment here. Here's the sun here illuminating the whole thing. I'll draw the sun properly. There we go. Okay. And so here's what happens next. We know then that the air near the road is going to be the warmer air because, well, it's near the hotter surface. It's closest to the hot surface. Okay. So think for a minute then. If you have air near a hot surface, is that going to be the more dense air or the less dense air? Remember now, it's hot air or warmer air. More dense or less dense? Okay, well, if you thought less dense, you're right, because this is the air that's closest to the road. It's going to be warm, and like in that simulation I showed you, the molecules are going to try to get apart, away from each other. Big spacing between here. So I'll just sort of write this as less dense, and I'll just sort of say that it also has a small n, small index of refraction. Less dense, small index of refraction. Okay. Now what happens is, of course, this isn't the only air in the room, but as you get a little further from the road, and this strictly is just not exactly what happens, but I'm just going to sort of maybe draw a little dividing line here to go, okay, that's sort of that layer of air. It's close to the road, it's warmer, it's less dense, but let's start moving away from the road now, where the air is going to get a little cooler because it's not so close to that hot road anymore. What's going to happen to the air now? More dense or less dense? It's getting cooler. Well, if you thought more dense, you're right. So we'll draw some air in here. And I'm on purpose here trying to draw the air molecules a little bit closer together now because it's getting more dense. It's getting cooler. And maybe I'll put a few more up here, make the layer a little bit thicker like this. I don't mean to drag my pen, but that's just the way it goes. And I'll put the other layer in here like this. So there's another layer here. And the way I would characterize this next layer then is I'll say it's a tad bit more dense. And why? Because it's just a little cooler. I'm not going to say a lot because it's still close to the road, but it's just a little cooler because it's further away versus this here, which is the least dense here. That's the hot air down there. And so I think you get the picture is what happens is as you get further and further from the road, you just start getting these layers of air density in here. And like this air here is going to be even more dense than the one just below it because the air is getting a little cooler still. Now it might be ambient, it might still be a warm desert day, but it's just not going to be as hot as it was as the air is down by the road, something like that, okay? And then I'll even go so far to say as you get even further from the road, let's just draw maybe one more layer in here, it's so much cooler and it's so much cooler that maybe even its density is going to be hard to capture. So I'm just going to have to color it in like this. You know, it's so dense it looks like that. Okay, so there'd be the air molecules like that. So that's the next thing about mirages. And so I'll probably end this video in just a second here to take a pause in the action. But generally, you could draw a little arrow like this going up away from the road. And basically, two things happen as you go away from the road. The air gets cooler. That's the first thing that happens. And the second thing that happens is it becomes more dense. Okay, so definitely for the mirages here, you have this air layering is what I'm trying to spell here. This air layering due to temperature. Okay? So that's the next piece in the mirage puzzle. So in the next video then, we'll get into showing what happens to the light as it encounters this really odd layering of air above the road.